This is the Component 2 Continuity of Life Taskbook, and we're up to question 7 about Warfarin as part of your variation and evolution questions. Here's a map somewhere in Wales, and prior to 1967, that was even before I was born, Warfarin was used in these areas. This was to control rats, so it's a rat poison is Warfarin. It thins the blood and kills the rats. And we've got the information resistance is given by a single dominant allele. So for example, W, big W would be the allele for resistance and little w not resistant, something like that. And the information here, as we're going out, we're getting later in time as the years go on. These are where the rats are found, so the incidence of rats found over the years. So they appear to be spreading out. So A1, how the warfarin resistant allele developed initially. Well, we've got probably our normal allele, but then suddenly this other allele appeared and rats became resistant. So that's by means of mutations. So base changes on the DNA would develop resistance. So mutations. Explain how this allele became common in that population. This is just the typical story that you're telling for any variation evolution kind of question, getting in all of your usual key points about evolution. So for example, we've now got some organisms, they show variation, and some have got a selective advantage. So the rats show variation, some are resistant, some aren't, and the resistant rats are at a selective advantage. So resistant rats are at a selective advantage. So it's good to use these words, like selective advantage or selected for that idea of selection. And so you just tell the story now. So more of these rats would survive. So and actually I'm better to say more there. So some of the others might survive as well, but more of the resistant rats survive. And so these so more resistant rats breed, and then what the question is about the allele, and so that allele is then passed on to the next generation. So that the beneficial allele, the resistant allele, beneficial allele is passed on to the next generation. And now it's almost partly repeating itself here. There are two ways in which the alleles for the resistance spread through the rat population. Well, we've already kind of touched on that these rats breed, so interbreeding or sexual reproduction. So interbreeding or sexual reproduction. But also a rat might just scamper off in a particular direction. Then there tend to be, rats would randomly move around, and so there'd be a natural kind of spread outwards of this allele. once it's common in the population. So migration of rats, or movement of rats. Migration of rats. Part B, we now are given a little bit more information. So animals with this allele for resistance need large quantities of vitamin K, which may or may not be available. And so if they don't get this extra vitamin K, they're unlikely to survive and breed. So if we're getting warfarin being put down, then the rats that are not resistant are going to die. And so our resistant rats, even though they need a bit more vitamin K, they've got the advantage. And here the question is actually, if we stop using, if we discontinue the rat poison, and it tells us the frequency of the resistant allele decreases. So we're just explaining why there. So we need to say, if warfarin is not used, then these resistant rats, they're certainly not at an advantage anymore. They don't need to be resistant. Then resistant rats are not at an advantage. So there's no selection for that resistance. In fact, they are at a disadvantage. They are at a disadvantage as they need more vitamin K. So they need more of the vitamin K. So in fact, they're going to be selected against. So resistant rats are selected against. So we're using those key words again, like selected against, or they're at a selective disadvantage, that sort of thing. And 8 marks.